Welcome to session 3 of Supply Chain Automation Pilot Program. My name is Jefferson Gardner. I'm the CEO and co-founder of Imbridge. We focus on emerging technologies and how these technologies will impact various industries. One of our primary industries is supply chain. In this session, we're going to be breaking this down into 3 subsessions, which include sales and operation planning, master production scheduling, and material requirement planning. In these subsessions, we'll explore the what and how-tos of why the order in which you conduct these various methods are important for efficiency and overall operational success. In addition to these core concepts, we'll also discuss process management mapping and how the management science approach can assist in recognizing opportunities for optimizing operational design. Sales and operations planning. What is it exactly? Sales and operation planning is a process that aims to ensure customer demands can be met by production, distribution, and purchasing. This practice focuses on closing the gap between supply and demand, also known as the Great Divide. The Great Divide of S&OP takes place between the supply hierarchy and the demand hierarchy. This Great Divide refers to the difficulty of balancing supply and demand within the market. To better understand this, let's talk about what parties are involved in both the demand hierarchy and the supply hierarchy. Your demand hierarchy includes your sales and marketing teams. The goals of sales is volume, while marketing seeks to obtain greater and greater market share. On the other side of the spectrum sits the supply hierarchy, which includes your supply chain team. The objective of the supply side is to get your product from its point of origin to the customer at the lowest cost and in the most efficient way possible. Although it may seem simple, disconnects happen when supply and demand hierarchies don't communicate. Failure to recognize their dependent roles can push the Great Divide even further apart. With sales and marketing being motivated by volume and market share, there can be a tendency to not consider the supply hierarchy, which will be responsible for filling the production and distribution of any additional sales. If the supply hierarchy cannot handle additional capacity, the demand hierarchy could increase volume and market share and unintentionally sabotage the entire operation because supply hierarchy cannot fulfill the additional sales, resulting in customer frustration and brand decline. Other considerations when developing your S&OP, what are important? Developing a value focus. This requires senior leaders to maintain focus on value creation for both the organization and the customer. Sharing knowledge across the organization assists in preventing departmental silos. If information isn't being shared, the chance of miscommunication and error potential increases substantially. Taking this a step further, if any organization hasn't mastered internal organizational communication, it's highly likely they do not have appropriate communication with their supply chain members, which then affects their supply hierarchy's success. Senior leaders must walk the talk once S&OP has been decided on and implemented. This means senior leaders keep each other accountable to plan as well as their teams. Agility also is key in balancing capacity and demand. To be agile requires continual communication regarding demand, capacity, and your ability to supply a product. Now that we've explored exactly what S&OP is, let's discuss the stepped approach. Now we'll explore the stepped approach to S&OP. Step 1, gather and manage data. Many companies lack concrete data strategies while simultaneously creating significant amounts of data. One key thing to keep in mind is data is now becoming more of a resource of power and value. So it's essential for these organizations to focus on a data strategy. Without a data focus, employee or consultant, you will likely lack the process to capture, clean, and structure data. Without clean and structured data, your organization will lack the capacity to effectively use your data to understand what has happened, why it's happened, and how to prevent problematic issues from recurring. Be cautious as some organizations oversimplify their data strategy by assuming their only data is found within their software systems. Your data strategy should include brainstorming sessions with leadership and employees to recognize where data can be captured and the value of collecting and managing it. Data management is the active and ongoing process of securely collecting and storing data within your organization. Robust data management plans are essential for organizations to realize that data is one of their most valuable intangible assets. Step 2, develop demand plan. Demand plans are focused on customer demand for your product. Keep in mind that with supply chains, there are often numerous customers throughout. However, the term customer most often refers to the final customer where the product requires no further physical transitions. Any good demand plan must include senior leadership, sales and marketing. Sales is responsible for reporting on current sales as well as assisting in the creation of forecast. This is covered by Chris in session 2. While marketing will assist in understanding market size, events that can trigger and increase or decrease demand, as well as create strategic marketing decisions to influence demand. With logical forecasts and relevant marketing information, you are now ready to develop or redevelop your production, distribution, and purchasing plans. Step 3, supply planning. Supply planning differs from demand planning as demand planning strictly focuses on determining the quantity of the products you need to produce to meet customer market demand, whereas supply planning focuses on the ability of your system to acquire the raw materials to produce the end product. The capacity of your system to produce enough product, as well as the ability of your supply chain to transfer all materials and goods from point of origin to the final customer in the most efficient way possible. Step 4, reconciliation of plans. The need for plan reconciliation lets you know that your S&OP is cyclical, and regularly planned meetings are required to ensure continuity between supply and demand plans. These reconciliation meetings should include all original members of S&OP. As a reminder, this would include senior leadership, marketing, sales, and other relevant members of your supply chain team. Meeting recurrence will depend on the complexity of your product, market share, and size of your organization, as well as the potential for emergency meetings to respond to various supply chain disruptors, from geopolitical issues and material scarcity to weather events and potential regulatory or compliance changes. As an example, COVID was a major disruptor to many supply chains, which created an urgent requirement for adaptation within an ever-changing and very quickly changing market. All good S&OP plans require also a very good process management. Well, what is process management? Process management, also called business process management, refers to the aligning of processes with an organization's strategic goals. Once goals are identified, the organization can map all processes and optimize these processes to achieve these goals. Depending on your organizational maturity, you may change how you will prioritize where you start your process mapping. You may already recognize bottlenecks that are impacting bottom line profitability. You may need to focus on quick process fixes, also referred to as tourniquet solutions. These tourniquet solutions will need to be revisited once the entire operation is mapped to create continuity between processes while optimizing the people, tasks, and technology interacting with each process. If you are a new business with no existing processes, this exercise is essential to doing things right the first time and will create scalability for your business. Although it may take you extra time up front to create your process management map, you will not regret it. This is essential, and you invest that time will return dividends to you. Design is the first step of creating a process, but also the first step when reevaluating a process. Either you develop the initial design or you critically analyze the existing design and look for design improvements. Designs can be crude representations of the entire process. This could be on a napkin. Once the initial design is written out, we can move to the next step of modeling the process. Modeling a process takes the basic process design and attempts to visualize it for concise and easy interpretation. This includes all tasks, technology, and people that interact within the process. This usually includes the use of flowcharts, diagrams, graphs, and other visualization methods. So what are these tasks, technology, and people? Well, tasks, sometimes referred to as sub-processes, are the individualized components that make up the entire process. This could be as simple as lifting a product from one part of the production system to the next. This task could be completed either by technology, people, or a combination of both. Technology. In this context, it's extremely broad. This could include any equipment, machines, hardware, and/or software, among others that interact within the process. People. This seems fairly common sense, but people are essential to consider within process management as it relates to the division of labor, which we will talk more about in session 6. Any task required to be completed by a person should be represented. Not only the requirement for a person to be involved with a specific task in the process, but the skills required to perform that task. Once modeling is complete and consensus with all stakeholders has been reached, the next step is simulation. Simulation is a soft approach to test the new model without disrupting the current operating design. Simulation could be produced through a digital technology or a soft implementation that simulates the new process at a point or time that does not disrupt current operations. In some cases, simulation will expose logical errors in the design process, which will cause stakeholders to return to the design and modeling stages in an attempt to improve the model before hard implementation. If all stakeholders are comfortable with the perceived success of the simulation, we then move on to executing the new process. Executing a new process can be very difficult, especially if your corporate culture is resistant to change. The people involved within the process must be trained or retrained, and full buy-in from all people involved within the process must take place for the new process to be successful. Resistance from any person or insufficiencies of technology within the process will result in a failed execution. Technological capacity and employee buy-in should be validated prior to execution. Once you've successfully executed the implementation of the new process, you must have a way to monitor its success. Implementation without monitoring is immediately a failure. Some process improvements may appear sound in theory, however, once applied could result in decreases in efficiency. So what exactly does success look like? Well, that's kind of up to your organization. Can it be measured? If so, what is required to measure it? And lastly, who in your organization will be responsible for the monitoring of the process? If organizations miss this step and don't assign a champion for the monitoring of this process, failure will be inevitable. Now that we understand the basics of process mapping, we need to understand some of the methodologies that will optimize or allow you to do this in a much more efficient way. And it's really deconstructing those processes down into those subtasks and looking at each individual subtask and trying to optimize that. You may only be able to obtain a little increase, but when you compare all subtasks and marginal increases for each, this can result in major benefit. One of these approaches is called management science, which is also referred to as Taylorism, and was a business methodology developed by Frederick Taylor in the early 1900s. His work explored how to optimize efficiencies within processes to reduce time to completion with the least amount of motion. Time savings is obvious on why we want to reduce time to completion. However, motion optimization was initially focused on to reduce human motions within production to reduce wear and tear on the physical body, while also optimizing time. Motion reduction focus also works within modern production systems that include robotics, as less motion will require less maintenance. Frederick's work became the foundation for Ford Motor Company's production methodology, where each task in the production cycle was analyzed using Taylorism, and with task specialization took the Model T production from 12 hours per vehicle to 90 minutes for full assembly. This is a massive increase in efficiency. So management science is important to incorporate when doing process mapping, as it allows you to critically consider your process with a focus on time and motion optimization, resulting in more production in less time, requiring lower maintenance. As a simple example to help make Taylorism less abstract, consider a restaurant that utilizes food assembly lines. Some examples of these types of restaurants would be Subway, Mucho Burrito, Five Guys, burgers and fries. Let's, in this example, take Subway. In this situation, we won't focus on the entire process of sandwich assembly. Instead, let's consider just the task of sauce application. The bottles at Subway often are a single nozzle, and when applying sauce, you often will see the employee lay 3 separate lines when they squeeze your mayonnaise on, 1, 2, and 3. To do this, the employee is required to produce 3 separate distinct motions, this way, that way, and back. If we were to apply the Taylorism method, we would seek to reduce these 3 motions into a single motion. We would do this by developing an application bottle that has 3 nozzle applicators that are separated by an optimized distance to assist in even sauce distribution. This may seem funny that we're obsessing over sauce application, but these are where efficiencies are found. This applicator bottle would only require one fluid motion across a sandwich to complete that task. This may seem negligible improvement for a single sandwich. However, when considering the number of sandwiches assembled in a day, this time savings adds up in a significant way. In addition, if the same approach was applied to all subtasks in the sandwich assembly process, we could obtain small improvement resulting in significant cumulative time and motion savings. A key point to not forget is the reduction in motion isn't just for time savings. We can reduce wear and tear on both people and equipment, reducing potential WCB claims for people or lowering maintenance requirements and increasing the longevity of your equipment. These types of applications, again, can seem small, but when you add them up, can increase efficiency, increase profitability, and reduce risk. So we've talked a lot about sales and operations planning, we've talked about demand hierarchy, supply hierarchy, and a variety of other methodologies from process management mapping to the management science approach. But when it comes down to it, what do you do first? How do you even decide on what to go after first? Because a lot of times these methods can be very complicated, and if you don't map out how the methods are supposed to go, you will run into errors, and you may put a lot of work into implementing one process initially, and you'll have to go back and redo that process. So what do you do first? Process management mapping before sales and operations planning? Well, it actually depends. What stage of business are you in? Are you at a concept stage, or are you managing an operating business? Most operating businesses have processes in place, whether these are intentional or not. From my experience from a consultancy standpoint, many companies know they have process, but they don't even know the subtasks that are required to complete that process. Many of their employees are simply going about their daily tasks, and they are left to choose the subtasks that are required for that completion. This can run you into a lot of errors. So this is why we typically suggest that you map your process before you focus on your sales and operations planning. Sales and operations planning before automation, or automation before sales and operation planning? Well, sales and operation planning should always be developed, even in a basic form, prior to exploring automation practices. Without S&OP, automation will be difficult and possibly impossible. So within all of these discussions, we really have to also account for risk considerations. We won't go into all of the risk considerations that could be implemented or are considered with all of these different practices. However, I wanted to focus on a few. One of which has to do with the management science approach. Often what happens within the management science approach is we have divisions of labor and very specific task specialization. So task specialization within division of labor often does not consider the employee involved in that specialization. The use of tailors and methods can disconnect individual employees from the purpose of the organization and restrict personal autonomy. It is essential to involve employees when exploring Taylorism methods, so work continues to be engaging for each employee within your organization. Considering risk with technology. Technology always carries risk. Any technological implementation into your operation should be carefully considered, reviewed, and tested to prevent downtime and operational failures. The last one that I'll bring up is people. People carry significant risk. They can be your greatest assets, but also the greatest risk factors within your organization. Ensuring you have ethically, integrity-driven individuals, as well as those who have a less propensity for error, is very important. People often create or are some of the largest problem or error creators within processes. And this is why automation is essential. However, we don't want to remove so much of tasks for people that then results in that disengagement with their job function and dissatisfaction with their employment.